This is our world, marvelous and vivid. And this is our home, Tainan, a great historical city and the first place in Taiwan. Our story of Taiwan began from here, and so does our team. In 2015, our population moved from aging to age, where more than 40% of our population are people above 65 years old. However, because of modernization, aging phenomenon, and unhealthy habits and customs, we now see more and more modern plagues and chronic diseases occurring. It is estimated by WHO over 1.5 billion people suffer from chronic diseases. Most of them are so-called metabolic syndrome, sharing one common leading cause, that is diabetes. Diabetes refers to excessive glucose due to your insulin resistance. When glucose surpasses the renal threshold, urine glucose then occurs. There are around 450 million people who suffer from diabetes in 2015. 44% of countries have taken no action, and in Taiwan, diabetes is the fourth leading cause of death. Diabetes has not only brought pain and death to the elderly, but it also been creeping its hands toward you, rather ruthlessly. And this is the truth. Face the reality and purity. We grieve our loss in the past with sorrow, but empower our future with vivid action that create a better tomorrow. But here's the thing, nearly one half of population undiagnosed. We think we are running for a cure, but really we are running away from a root. There's a saying in Taiwan, Taipei is Taiwan's pocket, but Tainan is a country's heart. So we're here to save our heart through early prevention by UKNOW. Think globally and act locally. So we're here to spread our idea universally. So now, iGEM NCKU is going to bring you UKNOW.
UKNOW makes you know your health condition from urine. UKNOW is a urine glucose biosensor. Through synthetic biology, aimed for diabetes prevention. Well, it is better than other commercial products in the market. For normal people like you and me, how can UKNOW help us? It is easy and simple. You wake up in the morning, walk to the toilet, and you just pee, and your urine will automatically be collected in UKNOW. In addition, you can get the result way before you get home, from the screen and even the app. But what's going on in our device? How can we make it as simple as possible? Well, here is a column with our E. coli, and a light source paired with a light detector, and even a filter that blocks away any other unnecessary light. And we use blue light to activate our E. coli. So if there is any glucose in your urine, our E. coli will emit the red light, and that is a warning sign that indicates you are at high-risk diabetic group or not. We even digitalize this biosignal and calculate the data by Arduino. To display our result even better, we code an app and even bring our UKNOW into your hand. Let's take a look at the bio part of our device.
E. coli, which is our genetically engineered E. coli, with two distinct functions. First, to detect the presence of glucose, we use MRFP with promoter PI. Promoter PI is a promoter induced by glucose through the mechanism of CAMP-CRP complex. As a result, the presence of glucose will induce the transcription rate of promoter PI, and the result is very clear, as you can see on the screen. To further characterize our system, we do some ELISA tests. After 2 hours of induction, our system can successfully differentiate diabetic with normal with 95% sensitivity. And if we prolong the detecting time to 6 hours, we can actually quantify the exact amount of glucose by the graph, as you can see on the screen. And for the next part, is our safety. Our safety system consists of lysis gene and promoter PBAD. Promoter PBAD, which is positively regulated by arabinose through the mechanism of protein ARAC and O2, I1, I2 operator site. Also, the presence of glucose will have a negative inhibitory effect on the transcription rate of promoter PBAD. So in conclusion, we can clarify the effect of arabinose and glucose on promoter PBAD. In our system, we put arabinose under our UKNOW, and when the urine comes in, the dissolved arabinose will cause our cell to lyse. As a result, we use a growth curve test to test the function of our suicide gene. The DFU test also proved its function, and for the next part is modeling.
In modeling part, we need to do some assumption and also a lot of calculation to figure out the formula which can tell the story of this mechanism. And we also find out that there are two different reaction paths in our mechanism. The research shows that if the glucose is present, then the transcription rate will be increased. The enzyme 2A plays an important role in our mechanism. In first reaction path, the enzyme 2A will facilitate the function of E2B, allow the glucose to pass through the plasma membrane to do the process of glycolysis. The other function of E2A is to activate the adenocyclase to turn the ATP into CAMP and bind with the CRP to form the complex. Finally, the complex will bind with the PI promoter to inhibit the transcription rate. And due to the competitive inhibition, we can say that if the glucose is present, then the transcription rate of PI promoter will be increased. We also find out that our recovery rate is 104%, which means that our device is very accurate. Besides, we use the software MATLAB to do the same thing to compute the data for us, so we can have the exact value of each unknown urine. Last but not least, if we integrate the transcription rate in different concentrations, then our device can precisely analyze the data in a range of 1 to 30 micromolar.
Human Practice has created another definition for iGEM. We have hosted the 2016 Asia Pacific Conference. We have collaborated with Taiwan's greatest genetic media, Gene Online. Diamond Biofund had provided modeling modes to launch UKNOW. We had interviewed with various experts. And that's for all our definition. I influence, G generate, E engage, M mainstream. As a conclusion, from wet lab experiment to human practice promotion, this is what we did for the whole year. That's all for our presentation. Thank you for your attention.